Hi friends, welcome to the session 3 of machine learning tutorial. So this session we are going to talk about concept learning. I'm Dr. P. Uma Mageshwari, Professor Department of Computer Science, College of Engineering, Guindy, Anna University, Chennai. Concept learning is a task of inferring a Boolean valued function from training example of its input and output. The other way we can say concept learning is the task of finding a hypothesis which is consistent enough. Let's assume there is a task or a problem, we can say, to find out which days actor Vijay come out to enjoy sports. The actor Vijay in the past experience have certain features like sky condition, humidity, temperature, wind, water, and forecast. So these are all called attributes of the day which takes on values. So many hypotheses. The problem is to find out the one which is consistent, for which we used to refer the past history, past experience with a function f of x. Learning task have a target concept, that is days on which Talabadi Vijay enjoys his favorite water sport. This is what the concept, target concept, with a given a set of example days, each represented by a set of attributes. The attribute for enjoy sport, that is what our problem, which indicates whether or not Vijay enjoys his favorite sport on this day or not. The task here is to learn to predict the value of enjoy sport for any arbitrary day based on the values of its other attributes. Now, let's come to the point of representing the hypothesis. Here, the task of finding appropriate set of hypotheses for concept learning in a given training data. This hypothesis is a conjunction of constraints which takes the form. It may have certain specific value, like if it is a water, it may be a warm water or a cold water. So straight value it can take, a specific value it can take. Otherwise, it may take don't care value. That means whatever it may be. That is, there is a question mark and no value allowed condition where there is an empty. Water is empty here, right? So there is no permissible value given attribute. Normally, the hypothesis is represented as a vector. All the attributes of the task is listed over here, like sky, air temperature, humidity, wind, water, and forecast. There are 6 variable attributes. The hypothesis, the initially, this is a sample one only. So the sky must be sunny, but the air temperature and humidity may be anything. The wind must be strong and water can be maybe there or not, and the forecast must be same. So this is one sample hypothesis, how it is formulated and frameworked. Here, the idea of satisfaction of hypothesis by some examples. So say the example which satisfy the hypothesis with a defined function h of x, where h of x is equal to 1 if this h is true on the particular sample x. Suppose if it is not satisfied, if it is not satisfied, then h of x will be 0. So that we have to find hypotheses that best fit the examples. And also we can reduce the learning through a search problem over a space of hypothesis also. That could be. So anyway, out of all in hypothesis, we have to find the best fit through a search problem. Understood? A scenario given, Vijay enjoys his favorite sport only on cold days with high humidity, right? We can represent this expression using the hypothesis. So first, only the specific air temperature. So that is what cold. And humidity must be also high. So only for 2 attributes, specific value given in this example. So the hypothesis is formulated By replacing the question mark, by replacing the attribute value given, the rest will be the question mark. So the most general hypothesis always takes the form all question mark. That means it is free to accept any value. The most specific hypothesis is all empty. That's phi symbol. That means no value allowed. Let's take the training examples for Enjoy Sport. The 4 instances I have taken here for all 6 attributes along with its label Enjoy Sport. So this concept learning is always supervised learning approach because the past experiences are all having label. The label is Enjoy Sport, yes or no, right? So C is the target concept here. And these examples have positive and negative. The first, second, and fourth one having positive examples because they have label yes. The third one is a negative example, it has no. Then the concept learning here is to derive a Boolean function from these by studying this example to generate a hypothesis. So the prototypical concept learning task is include 3 components like T. That is what the task which predict when person will enjoy sport or not. The target function here is C. For any enjoy sport sample X may take the C may take 0 or 1 value. The form of hypothesis always the conjunction of literals we know. So that is a sample we have taken. And experience E here is the instance, the number of instances, possible days, whichever is observed in the past, describing all the attributes what we have considered here. The training examples here will take the form from the instance, the positive negative examples of target function x1, c of x1 till xm, c of xm. Here we have to understand that x1 is the first instance, right? The first instance is here given here. So if you take this instance, x1 is here, right? x1 and its concept and its label. Likewise, you have to take it, right? So there is a set always x1 comma c of x1, x2 comma c of x2, x3 comma c of x3, x4 comma c of x4 for the previous table what is shown. Then the performance measure. As per the machine learning algorithm, these 3 things are very important. We know what is machine learning. So performance measure P, here is the hypothesis H in the hypothesis space capital H, such that H of X must be C of X for all X in D. This is what the measure. So there may exist several alternative hypotheses that fit the example. But by the search strategy, we have to find the best fit. Now, let's come on to the inductive learning hypothesis. Any hypothesis found to approximate the target function well over a sufficiently large set of training example will also approximate target function well over other unobserved example. This is what the basis for this concept learning. That is why this phenomenon is called inductive learning phenomenon. Inductive learning is the one where if you learn something from the past, with that knowledge, we can predict the future. That is what is rewritten here. In the same way, concept learning also works. Here I said there is a lot many hypotheses which is fit for a certain at. We have to find the best fitting one. That may be a search problem. So concept learning can be viewed as the task of screening through a large space of hypotheses implicitly defined by the hypothesis representation. Right? So the goal of the search here is to find out the best fit hypothesis that best fit the training example. Now the definition of the space for all hypotheses, instance X and hypothesis H, the instance space X and hypothesis space H. X attribute we have given. The first attribute sky has 3 possible value, like S will be having 2 values. So that the instance space can have exactly the number of possible values for each attribute multiplied together so that 96 distinct instances. Here there are two things. One is syntactically distinct hypothesis within H, which may be calculated by adding two more attributes with the existing values, question mark and the pi symbol, right? Because there is a chance of attribute value could be a question mark for some time, could be a pi for some time. So we have to add two more values. So now this instance space X contains, add two values with all the values here over here. So 3 plus 2 is 5, 2 plus 2 is 4, likewise. So we have 5,120 distinct instances. Okay. Now, these are all 5,120 distinct instances are syntactically distinct hypotheses within the space H. Next, a concept, semantically distinct hypothesis. Here, every hypothesis containing one or more 5 symbols that represent empty set for every instance. Okay, that is, it classifies every instance as negative also. So therefore, the number of semantically distinct hypotheses is only here. We have to syntactically distinct hypothesis. We have to reduce every value by 1. So 5 reduced to 4, 4 reduced to 3, 3, 4 again to 3, 3, 3 and all. And finally, value is added, plus 1 is added to mean that so 973 distinct instances will be there. So syntactically distinct hypothesis, semantically distinct hypothesis is calculated in this fashion. Which is for Enjoy Sport learning task, we have the attributes, 6 different attributes as given here. The possible values for every attribute, sky will have 3 attributes, sunny, rainy, cloudy, air temperature, 2 attributes, warm and cold, such a way humidity, wind, water and forecast have two values. So this is how, for our own example, this is the calculation for syntactically distinct hypothesis and semantically distinct hypothesis. The similar way how actually the previous slide gives us an example computation. Here I have explained how many the attributes and its corresponding value and how these numbers are basically taken out, right? Then syntactically distinct and semantically distinct hypothesis calculation is given. Now, general to specific ordering of hypothesis. While organizing the concept learning as a search through the hypothesis space, we have to follow the strategy called general to specific ordering of hypothesis. To illustrate this ordering, there are two hypotheses. One is H1 taking the form sunny, question mark, strong, question mark. For all the 6 attributes, only the first and fourth attribute have specific value, the rest having common value. And the H2, the second hypothesis, take first attribute specific value sunny, the rest are question mark. There are 2 different hypotheses. Now, consider the set of instances that are classified positive for H1 and H2, because H2 is here impose few constraints over H1. H1 is very particular than H2, we can say. H1 sees whether the air temperature, H1 sees whether the sky is sunny, as well the wind is strong. But H2 says only the sky must be sunny, the rest can be anything. So H1 is more specific than H2. But other way we can say H2 is more general than H1. So when this condition happens, H2 is more general than H1. How? General to specific order. There are 2 approaches for concept learning searches. There are 2 approaches for concept learning algorithms. One is approach 1, which is search based on ordering of hypothesis. Approach 2 will search based on finding all possible hypotheses using good representation of hypothesis space. This is the ordering of hypothesis search space, where you see here there are 2 things. What we have taken is instance space, capital X, hypothesis space, capital H. The instances are all here, x1 and x2 is given here, x1 and x2, and with its relative values for all 6 attributes. And hypothesis space, there are 3 hypotheses. One is sunny, question mark, strong, question mark. Another one is H2 and another one is H3. If H is more general than H dash, it must be represented as H greater than or equal to H dash, instance X, right? This is how we used to represent more specific ordering of hypothesis, more general than relation. If H is more general than H naught, H dash, like here H1, H2, H3, which is more general? I think the H2 is more general, right? So H2 is greater than H1 as well H3, right? This is how we have to represent.